Hello, we are the team number 2, and we're going to talk about methods for robot programming. My team is Daniel Arun, Alejandra Martinez, and me, Sofia Yebra. First, for the methods for robot programming, we have the guided programming. This first method, the guided programming, consists of making the robot perform the tasks by moving its joints manually while recording the movements captured by the sensors. For subsequent repetition automatically, it should be noted that this guided programming can be done by making a scale model of the robot to facilitate the movement of the joints. The next, please. Well, we have here the same guided programming. The next, please. And we have the basic guidance. The robot is guided consecutively through the desired point during the automatic execution phase of the program. During this phase, the control unit interpolates these points according to the certain trajectories. In many cases, it is not possible to include any kind of control structures within the program. So the points are always traversed sequentially in the same order in which they were programmed. And we have the extended guidance. This allows you to specify, together with the points through which the robot must pass, data relating to speed, types of trajectory, precision with which you want the points to be reached, program flow control, attention to binary inputs and outputs, etc. In this case, the guidance method used is that of the joysticks. Extended guidance programming greatly increases the power of the programming system. And we have the textual programming. The textual programming methods allow to indicate tasks to the robot through a specific programming language. A program is understood as a series of commands that are edited and subsequently executed. Therefore, there is a text for the program. Textual programming can be classified in 3 levels. Text-based or textual programming refers to the sequence of instructions that make up an algorithm read in a given programming language, based on the rules established in the language itself. This set of sentences is parsed and translated by the processor to perform the task for which it was created.
Requirements of a robot programming system. Despite of the lack of standardization among existing robot programming methods, common requirements have led to a certain parallelism and affinity among almost all of them. This circumstance makes it possible to establish a series of general characteristics that are manifested in the programming elements they contain. The environment development. Like any conventional programming language, it is of great importance in order to achieve a considerable increase in programming productivity. Programming the actions of a manipulator is complicated in the sense that all the times there is an interaction with the environment, being a continuous process of trial and error. This is the main reason why most of the robot programming systems are on the interpreted type, being able to track step by step what is programmed at each moment, thus avoiding the tedious cycle of edit, compile, execute, very costly in time. Environment modeling. The environment model is the robot's representation of the objects with which it interacts. The models are limited to geometric characteristics such as position and orientation of the objects, and sometimes to their shape, dimensions, weight, etc. The models of the environment allows to locate yourself, plan paths, plan complex tasks, and to act autonomously and infer new knowledge. Types of data. The basic types of data, also called primitives, can be roughly grouped into three: numeric, logical, and text data types. Among the data types, two are worth mentioning, such as the character type and the string type. Mm, the inputs and outputs management. The inputs are the data that a robot collects, and the outputs are the commands it sends after processing the input data according to a program it has stored. They are digital when they take only two values, and there's also the control devices such as there are such as programmers and processors that receive and adjust the signals. Communications. For robots to become a valuable asset in an automated manufacturing environment, they need to be able to communicate either to other robots, which may be part of the same system, other automation technologies, or production planning and scheduling systems to receive or transmit data. Binary signals. These are effectively simple on and off signals and generally used as inputs or outputs, either to confirm that a part is present or to switch on or off ancillary equipment. These signals can also be sent in a group as a binary coded decimal to pass numbers in a binary format between different machines.
Analog signals. Analog inputs and outputs are used by robots to either revise a value in the front of a voltage which can then be converted to a number. While term is send a voltage, which is converted and used by an ancillary piece of equipment to set or change one or more parameters. Signal serial or parallel interface. Use a personal computer PC is linked to peripheral equipment such as a disk drivers and printers using standard parallel or serial ports, so too can robots. Networks has automation standard to become more sophisticated, and a great number of different systems and devices became available in AP manufacturing automatic protocol developed in the 1980s was at the time seen as a solution to enable communications between what were underused in telecommunication standards. Special interface. Special interface application has a RC welding requiring several analog and digital signals to control the welding power supply and filler wire feed drives. These are often available as standard sets from the robot vendors with special instructions with the robot programming language to control them in application-specific manner. Robot movement control. In this page, you can see 12 points control, like expression constraint condition setting, inequality constraint condition setting unit, reducing dry method setting unit. All of them are conform of system. So how to move a robot with control. There are the second case of how move a robot with control. And this is the execution from control with a star and nine spots like quality constraint condition entry, quality constraint condition setting, and quality constraint condition entry and quality constraint condition setting, reducing dry method entry, reducing dry method setting, quadratic programming, problem solving, numeric integration, entry bot joint driving. They are the conform of the of TIS, United States Patent Application Publication, in Alaska about the robot movement control system. Thank you.